Here we go. Oh, got my favorite student, good old Anne. Sometimes I spell her last name with a Y, sometimes with a double E. I'm whimsical that way. Here we go. Number 1, a 1,200 kilogram car is moving east. You know what? As soon as they give me directions, I have a temptation to maybe do that because I feel better. At 30 meters per second, and it collides with a 3,600 kilogram truck moving at 20 meters per second in a direction 60 degrees north of east. Angles. Ding, 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 ding. Angles, 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 angles. So I'm already thinking I'm going to be drawing things tip to tail. And the fact that it's a 60 degrees suggests to me it's not going to be SOHCAHTOA, it's going to be sine law, cosine law, because it's not a lovely 90 degrees. The vehicles interlock and move off together. Find their velocity after the collision. Did I say collision? Why, this is a job. Yeah, change colors, Mr. Duke. This is a job for conservation of momentum. I'm going to call this mass 1. I'll call this, oh, you know what? Car and truck, I'm going to call this mass C, and I'm going to call this mass T. That works. Before the collision, what's moving? The car, the truck, both, or neither? The car? Clay, you do those true-false tests where you also do that thing, right? And you're like, what do you think that is? It's like a fruit. It's a fru. It's a trough. I think both. Yes? Stuck together or separate? Before the collision. Separate. Momentum car initial. Momentum truck initial. Wham! They collide after the collision. Stuck. I think both are moving stuck together. What's the fancy word for when they stick together? I always got to think about it. Inelastic. Okay. Angles? Yeah. Now, if there was not angles, I would now go MCVC plus MTVT equals math of both, and I could just divide and get whatever I wanted to by itself. But because angles, I better dulp. So it looks like the car east. How big? 1,200 times 30. I think 36,000. Is that right? Because it's the momentum that's conserved. Plus, what's the direction of the truck? 60 degrees what? North of what? North of what? North of. So I'm going to draw east first. What of east? $60 degrees. And how big will this line be? It's going to be mass times velocity, 3,600 times 20. I think 72,000. Is that right? Which means I should actually, when I draw that triangle, make that slanty line twice as long as the horizontal line if Dustin and I want to be roughly to scale, and I'm a nerd. I kind of want to do that. I really need to retype this quiz and give more room to work because this is going to be really crammed. But I can do this, I guess. So it's going to end up being 36,000 72,000, and here is what I'm trying to find. I need an angle. How big is that angle? How'd you get the 120? So I visualized that this little thing there was 60. So I said this has got to be 120 because a straight line is 180 degrees. Cool. Cosine law. Wow, I really didn't leave much room here. Oh well. It's going to be momentum both squared equals 36,000 squared plus 72,000 squared minus 2, 36,000, 72,000, cosine of 120. Ran out of room. 36,000 squared plus 72,000 squared minus 2, 36,000, 72,000, cos 120. Wow. Oh, square root. And I get the final momentum of both is 95,247.0472. That there. Momentum of both final. 95247. You know what? That's 5 sig figs, and there's a 0 there, so that's probably as good a place as any to stop. I'll probably use my answer. Now that's the momentum. How can I make that into a velocity? It's going to be 95247 divided by, I guess, divided by the mass of both. Okay. Divided by, I don't know if you can see from the back there, but I am dividing by 1200 plus 3600. Sorry, it's so small. Dividing by 1200 plus 3600. And I get 19.84. Oh, this is my final answer, 19.8. At. Which angle am I going to use for the at? Bottom left or top right in that triangle? One up there or the one down there? Why? I always set my direction from where the vector that I'm interested in starts. Not where it ends up pointing to, where it's coming from. I want that one. I think if I write fairly legibly, I can fit it all right there. Because I think it's going to be the sine of theta over 36,000 or over 72,000? Over 72,000 equals the sine of 120 over P both. Oh, which I know. 9, 5, 2, 4, 7. I think it's going to be 72,000 sine of 120 divided by 9, 5, 2, 4, 7. Inverse sine of that. And I get, I'll call it 41 degrees, 40.9 degrees. I'll go 41. Vikas, you going to make it? Yep. It's a long blink. 41 degrees. What of what? North of south, east of west? What of what? East of north or north of east? North of east. Good. If you got that, 4 out of 4. Otherwise, yeah, I'd probably do something like this. Half mark for cluing in its conservation of momentum, because by the end of the year, if you remember that, that's important. I'd give you a half mark if I saw that equation. I'd give you a half mark for your little vectory pictures there. I'd give you a half mark for the vector triangle. I'd give you a half mark for the cosine law. I'd give you a half mark for that, a half mark for that, a half mark for that, and a half mark for that. I think that's 8 halves. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 halves. No? You know what? I'll say that, and I'll let you draw the triangle different. By the way, the other way you could have drawn the triangle is you could have drawn the 72,000 first, and then the 36,000. You'll get the same 19.8, but I think you'll get 49 degrees east of north, I think, which is the same answer. Whew. Number 2, oh thank God, it's in a straight line. Here's our ballistic pendulum. Pendulum is hanging from a massless, frictionless string that is 15 meters long. Why'd they tell me the length of the string? Just to give you a number to worry about and confuse you. I don't think you're going to use it. I don't think. The pendulum weighs 2.5 kilograms. A 0.15 kilogram bullet traveling at 250 meters per second hits the pendulum and sticks. I think we call that inelastic. What height? Oh, so I would argue this question has 2 parts. The collision, and then the swing up. I think in the collision we have this. Did I say collision? I used the words pendulum and bullet, so I'm going to call this mass P. I'm going to call this mass B. You could call them 1 and 2 or whatever system that works for you. But what I am going to say is before the collision, what's moving? Mass B, mass P, or both? I think before the collision, just the bullet. Yes? Wham! They collide. After the collision, what's moving? The bullet, the pendulum, both, or neither? Both stuck together or separate? Angles? No, it's in a straight line. Oh, thank God. So now I can just say, okay, mass of the bullet, V initial of the bullet, equals mass of the pendulum plus mass of the bullet, V final. I can say, hey, V final is going to be mass of the bullet, V initial of the bullet divided by mass of the pendulum, mass of the bullet, and now I can plug and chug. What was the mass of the bullet? 0.15 kilograms. What was the 250? Wham, they collide. 2.65. I went 2.5 and 0.15 in my head. Is that okay? Just because I'm kind of running out of room here. And I get, after the collision, they move off at 13 point something, somebody said? No! I hit the wrong thing. 0.15 times 250 divided by 2.65. 14.15? Oh, I thought I heard 13. I'm going to go 14.151 since this is not my final answer. And that 0, that 9 makes that the 1. That's a nice place to round off to. So I'm going to go 14.151 meters per second. Now we swing. Well, that sounds like a change in height, change in speed, yucky, curvy path. Not the sum, Mr. Dewick. KE initial plus PE initial equals KE final plus PE final plus heat. If it was talking about friction, doesn't seem to be. So Travis, I'm going to ignore that. Yes? PEI gets hosed again. Yes, we come to a stop for a split second. So we're going to get a half M both V initial squared equals M both GH. I wrote in this is a quiz, so I'm being a bit more careful. I think in our homework we just kind of said, are the L's the same? Here, I just made little notes along the way. Are they both M boths? Well, then the masses cancel. In fact, I think it could be argued that the height is going to be VI squared all over 2G. which is going to be all over 2 times 9.8. What the heck is VI? Oh, 14.151 squared. Because that number, although it's the final velocity after the collision, it's the initial velocity of the swing. Squared divided by 2 times 9.8. You get 10.2? And I'd take like 10.1 and 10.3, but 10.2, yes? Meters. If you got that, 4 out of 4. Otherwise, I'd give a half mark. I'd give a half mark. I'd give a half mark. If you were able to find V final after the collision, V initial at the beginning of the swing, that gets you 2 out of 4. And then I'd probably go a half mark, a half mark, a half mark, and a half mark. I told you guys the story about the kid who tried cheating from one of my answer keys and wrote in all the 1/2 thinking that it was part of the answer. Yeah, okay. I told him the good news is you suck at cheating, and you figured that out in high school, not in university where they expel you and keep your tuition. So glad you figured that out now. Bonus from previous question. Bonus, you say? Suppose the pendulum only reaches a height of 5 meters. How many joules of energy were... Oh, you know what? I think this is still... But now I'm going to add heat. And I think at the top we're still at rest. I think we're still starting on the ground. So I think the heat is going to be KE initial takeaway PE final, which is going to be a half mv initial squared minus mgh final. So the heat is going to be 0.5. Which mass? Oh, both? What was both? 2.65? I'm going from memory there. VI was 14.151 squared minus still 2.65, 9.8. How high did we get? Only 5 meters. How much was lost? Let's find out. A half times 2.65 times 14.151 squared minus 2.65 times 9.8 times 5. You get 2,523 point... I'm going to go 2520. Is that right? No? Yes? Am I wrong? I could be. Let's check my writing. Squared minus m. Isn't that right? Am I right or wrong, folks? Did you get that? Did you get that? Okay, if nobody got it, maybe I'm wrong. Let me think here. This is correct. Yes? Yes. How many joules were lost? So, to heat and sound that occurred during the collision. So my initial is still 14.5. I only went that high. Where'd the extra energy go? This should be right. A half mv squared. We're minusing the PE final over the mgh final. I think I'm getting 2520. But, yeah.
Is that on your calculator?
Oh, did I type it wrong? That's a good question. Ah, thank you. See it? That'll make a difference. by a factor of a chunk. How about 135
Yep.
joules? Thank you. Because that number also seemed terribly large to me. I was going, that's a lot of heat. Bonus mark, all or nothing. Sorry. But I would take 134, 136. It depends how many sig figs you carried here, but carry extra sig figs if you know you're going to use the data later. Holy smokes, Mr. Dewick, number 3. 125 kilogram shell explodes, boom, into 3 fragments. Fragment, I see angles. Is this an explosion? That's a job for conservation of momentum. The sum of all the momentum before equals the sum of all the momentum after. Before the collision, what was moving? Piece A, piece B, piece C, all or neither? Neither. So what was my initial momentum before the explosion? 0. So what's my momentum going to be after the explosion? Still 0, but I'm not going to write a 0. Instead, I'm going to say, after the explosion, what was moving? Piece A, piece B, piece C, all of them or none of them? Stuck together or separate? I could put finals on all of those, but since that's the only momentum kicking around, I'm being a little bit sloppy. Angles? Ugh. Yeah. So it's still going to be 0 equals, but it looks like, well, what's the direction of piece A? What's the direction of piece A?
30 degrees
North of what?
north of east.
North of what?
North of east.
So what am I going to draw first?
East.
What of east?
North.
How many degrees? I'll put a little 30 in there. So here is piece A. If I go mass times velocity, 75 times 32, I get, is it 2400? Is that right? Yay. Plus piece B. What direction does piece B fly?
20 degrees
North of what?
What?
North of what? North of what? What am I going to draw first?
West.
What of west?
North.
How many degrees?
20.
It's going to look like that. Okay. How big is that one? 40 times 48. 1920? Do I know what PC looks like? I have a feeling I'm going to need more room, so I'm going to do that. Plus, yeah, I don't know what C looks like. Okay. Well, I got 2 vectors. Any thoughts on how I could add those together? Tip to tail. So it's going to look like this. 2400. 1920. Might be longer, might be shorter. I'm not sure. What will the resultant look like? Or what am I looking? What will piece C look like? Is it going to be going up and to the right, or is it going to be starting on the top and going down and to the left? Why? Because I know that this has to add to, and 0 as a picture looks like that. Here is piece C. The angles are going to be pretty tough. Let's see. I'm going to really mark up my diagram an awful lot, and then I'll erase it so you can see how I put it together. Well, I noticed next to a horizontal line going up, how big is this angle right here? So if I imagine that, How big is that angle right there? Okay, that's 20. You okay with that, Kohei? Zoom, zoom, zoom. That's 20, that little chunk right there. Remember that. I notice this 30 is below the slanty 2400. I notice this 30 is right there. Wait a minute. I can do the same trick. If I do that, how big is that angle? 30? How big was this angle? How big is that whole angle there? 50. To talk your lingo. 50, yes? Mr. Dewick, will you give us one that tough on the test? I might feel comfy as a multiple choice nasty, but I think on your written ones, it'll be much easier to move the angles around. The reason this one is so nasty is because none of the original lines are horizontal or vertical. I didn't give you any nice lines. So, if I hear you guys correctly, and I think I do, you're telling me that's... Yes? Yay! Cosine law! Piece C squared equals 1920 squared plus 2400 squared minus 2. 1920. 2400 cos 50. Yeah, Vikas, I'd be nodding too. This is a lot of work. Squared plus 2400 squared minus 2 times 1920 times 2400 cos 50. Square root. Did you get the final momentum being 1876.824? That? I'll go 1876.82. Is that right? People nodding? Okay. 1876.82. That's not what they wanted me to find. I want to find the velocity of piece C. How can I find the velocity if I know the momentum? Okay. Mr. Dewick, you didn't tell me the mass. Well, I sort of did. Jason, what? Which is? Yeah. Which were? So piece C, only 10 kilograms, which, by the way, also suggests I think it's probably going to be moving the fastest. If I get it moving the slowest, I'd be a little suspicious, because momentum is mass times velocity. So I think a lighter mass, you'd be kicking, right? Here's the really nice thing. I can divide this by 10. Is it 10? I can divide this in my head. 18. It's going to be 188. No, that's a lie. Yeah, no, 188. Yes. 187.68, but I'll go to 3 sig figs now. Is that okay? At where is my vector starting from? Here, except that's a slanty of a slanty. To that I say, Any suggestions? Sorry? I didn't hear you. Is this trig? Oh, the Z trick. Where? Like that? Like that? Oh,
You know that
that thing there is, that I just drew, 20. So this up here is 20. Oh, I wonder if that'll help. Let's see. So I think we're still going to find this angle, because it's about the only thing I know. I mean, I don't want that one. That's worth pointing to. I'm going to find this angle, and then I'm going to think for a while and see what else I can figure out by adding horizontal and vertical lines, and hopefully I get something. I think Josh is on the right track. Let's first of all find this angle, theta. It's going to be sine theta over 2400 equals the sine of 50 over 1876.82. $2,400 sine 50 over 1876.82. Wow. Shift sine of that. I get 78.4 degrees. Is that right? That looks kind of okay with my roughly to scale picture. I'd be worried if it said 10 degrees. I'd be worried if it was bigger than 90, because it's not that. Okay, so how big is this angle? I'm going to label that now. How big is this angle here? What do those add to? 90. Okay. Now, if you said 98.4 degrees south of east, I'll take that. But I'll be honest, I think now what I'm going to do is bail. I'm going to find that angle, which I'm pretty sure is 180 minus 78.4 and minus the 20. I think 81.6. I think one possibility is 81.6 degrees. What of what? North of south, east of west, what of what? What of what? I think that is south of west. Whew! Or I would take 8.4 degrees west of south, or, and this is technically wrong, but this is a tough enough question, I'll live with it, I would take 98.4 degrees south of east, which I guess you could argue would mean going and ending up past 90 degrees, which is, I guess, what that green line looks like. Is that okay, Clay? You don't have to like it. This is tough. How do you give out part marks for that, Mr. Dewick? Ooh, boy, great question. I would probably go something like this. 1 mark for the 188. 1 mark for the angle. How many marks should I make this worth? Only 4? This would definitely be a 7 marker in reality. I would give you 1 mark if you would recognize that the momentum was 0. If I saw that somewhere. And I'd probably give you 1 mark if I saw that you'd managed to find that 1876.8. Whew. Clay said, would you give 1 mark for the drawing? Honestly, if I get, first of all, let me be clear. There is going to be on your test an explosion. Boom! But I won't give you a sine law, cosine law as part of it. It'll be lovely right angle SOHCAHTOA. In other words, the pieces magically, Max, will fly off due north, due east, due south, or due west, which means you'll have right angles. Okay? And then, Clay, I would have no problem, and I would probably give you like 1 mark for the vector triangle or something like that as well. Okay? Is that all right? Can you give yourself a score on this pretty nasty quiz out of 12?